In the rapidly evolving landscape of open-source artificial intelligence, the release of Deepseek v3.1 quietly marked a seismic shift, one that few saw coming and even fewer fully appreciate. While OpenAI's GPT-OSX-20b entered the stage with fanfare, promising democratized access and agentic capabilities for the masses, it was Deepseek v3.1, the work of a Chinese startup, that quietly and decisively outperformed its competitor across key benchmarks. Here, we unpack how Deepseek's hybrid architecture has raised the bar for open source models, and why the future is likely to hinge not just on raw performance but on the developer communities each model inspires. OpenAI's GPT-OSX-20b arrived on August 5, 2025 amidst much anticipation. With the promise of running on consumer-grade hardware, it aimed to bring powerful language modeling to anyone willing to download and experiment. The model featured 20 billion parameters and was accompanied by a larger version intended to compete with heavyweights like Meta's Llama 4 and DeepSeek's newest release. The premise was seductive: full local control over your AI, no data leaving your machine, and no prohibitive API costs. But as the dust settled, the excitement gave way to practical testing, and the results told a different story. Ched and only report their PIDs. Or would you prefer to restart them manually on Yo? Just 2 weeks after OpenAI's rollout, Deepseek AI dropped v3.1 with little more than a tweet and a download link. No press release, no orchestrated hype, just a model with a hybrid thinking architecture, capable of handling a 128,000 token context window and boasting a staggering 685 billion parameters. It was a bold answer to OpenAI's public comeback, and the AI world took notice not because of marketing but because Deepseek delivered where it mattered most. The first battleground was code generation. In this arena, Deepseek v3.1 flexed its muscles. When prompted to produce a minimalist 2D stealth maze game, a test requiring logic, structure, and functional code, Deepseek generated working game logic on its very first attempt. The code was not just bug-free, it was immediately playable, easily iterable, and robust. While the user interface wasn't as sleek as what proprietary models might create, the foundation was solid. By contrast, OpenAI's GPT-OSX-20b stumbled. In high reasoning mode, it churned for over 21 minutes before timing out with no result, and in medium reasoning, it spat out broken, unusable code in less than 11 seconds. With zero-shot prompting, the gold standard for open source evaluation, Deepseek delivered, while OpenAI failed to execute. But coding is only part of the story. In creative writing, Deepseek v3.1 again emerged as a leader when both models were tasked to write a story about a historian from the year 2150 traveling back to 1000 AD to prevent an ecological disaster, only to discover he caused it. Deepseek's narrative stood out. Its descriptions were vivid and immersive. The air was a physical thing, a thick broth of loam, contrasting with the sterile society the protagonist left behind. The story's logic held together with tribal interactions and the unfolding paradox carefully grounded in historical plausibility and emotional resonance. OpenAI's model, meanwhile, produced a narrative riddled with inconsistencies. Characters responded to languages and concepts they couldn't possibly know, and the plot stakes felt abstract and disconnected. Deepseek's story was gripping and coherent, OpenAI's was superficial and muddled. In logical reasoning, the divide grew even sharper. Deepseek v3.1 efficiently solved complex logic puzzles and mysteries on its first try, demonstrating advanced chain-of-thought capabilities that didn't require explicit prompting. OpenAI's GPT-OSX-20b, on the other hand, tended to overanalyze, burning through its context window, searching for hidden patterns that weren't relevant, and often failed to reach any meaningful conclusion. When tasked with deducing the identity of a stalker in a mystery scenario, Deepseek delivered a plausible answer, while OpenAI got stuck in endless loops, producing either no result or a wrong answer. Handling sensitive topics, Deepseek demonstrated another key advancement. While both models adhered to default safety protocols, Deepseek provided thoughtful refusals. Instead of simply declining to answer unethical queries with boilerplate responses, it explained why the topic was problematic, providing context and, in some cases, compassionate advice. When questioned about addiction crises, Deepseek reframed its refusal with empathy, offering harm reduction strategies and resources for recovery. OpenAI's model, in contrast, defaulted to terse denials with no explanation, often leaving users frustrated and unsupported. Yet not everything was tilted in Deepseek's favor. OpenAI's GPT-OSS20B scored a major win in customizability. The open source community quickly produced pruned versions tailored for specific domains: mathematics, law, science, and more. These specialized models traded broad capability for excellence in their chosen niche, and developers stripped away censorship and fine-tuned the model for a variety of use cases. Deepseek, still new to the scene, lacks this breadth of community-driven adaptations. Its quantized releases, preserving all parameters at lower precision, allowed the full 685 billion parameter model to run on modest hardware, but the community hasn't yet built the specialized derivatives that give OpenAI's model lasting relevance. This difference is crucial. Open source AI thrives on community engagement. The best model doesn't always win. The model that attracts and retains developer attention becomes the one that improves most rapidly, finds new applications, and ultimately becomes indispensable. For now, OpenAI's GPT-OS20B is easier to modify, and the community has already shown its potential to transform a flawed base into a world-class tool for specific fields. Deepseek's quantized versions offer exciting possibilities for industrial applications, but widespread community adoption will be the true test. From a hardware perspective, both models require careful consideration. Running large language models locally isn't as simple as logging into a cloud service. Even the smaller models demand significant GPU resources or clever quantization to run on consumer devices. This means that for now, open source is mostly the domain of developers and researchers, those with the technical expertise and hardware to unlock their full potential. Over time, as community-driven optimizations proliferate, these models will become accessible to casual users on everyday devices. In summary, Deepseek v3.1 represents a new standard for what open source AI can achieve out of the box. Its hybrid architecture delivers robust performance across coding, creative writing, logical reasoning, and sensitive topics. It is the embodiment of China's ambition to lead in AI innovation, and its success demonstrates that great models can arise quietly, without hype, simply by excelling at the tasks that matter. OpenAI's GPT-OSS20B, while struggling in its initial form, holds immense potential thanks to its customizability and the vibrant developer community that surrounds it. If history is any guide, the stock model may be outperformed today, but the derivatives built by engaged experts could dominate tomorrow's specialized applications. Ultimately, the fate of these models will be decided not by benchmarks, but by the communities that rally behind them. Deepseek v3.1 has set a high bar for performance, logic, and creativity. OpenAI's model offers a foundation for endless adaptation. In the open source world, the real winner will be the model that inspires the most innovation, collaboration, and practical impact for users everywhere. The race is far from over, and the next breakthrough may be just a pull request away.